Hi, welcome to our lesson on 7.7 of mixture problems, which is basically calculating the amounts needed to make certain mixtures. For example, chemists, druggists, grocers, and others frequently use percents to mix solutions or ingredients. So, we'll be mixing ingredients. Our first problem states a grocer makes a natural breakfast cereal by mixing oat cereal costing $2 per pound, and cereal with dry fruits costing $9 per pound. I should say per pound, not per pounds. How many pounds of each cereal are needed to make 60 pounds of cereal costing $3.75 per pound? So please write this problem into your notes as well as the filled in fields of the amounts. We'll be using a chart for this mixture problem, so here's how we set it up first. Go ahead and please copy down this chart. So on the left side we have cereal, fruit, and mix. And on the top headings we have pounds, the price per pound, and the total cost. And filling this in, we don't know how many pounds of cereal we have, so we're going to represent X for cereal. And since I want to make 60 pounds total of cereal, I'm going to write 60 minus X for the fruit, because whatever's left over is the amount of pounds for the fruit cereal. For the price per pound of the oat cereal, that's $2 per pound. And the fruit cereal is $9 per pound. So the total cost of the oat cereal is 2x, and the total cost of the fruit cereal is 9 times 60 minus x. Then in my mix, I'm going to have 60 pounds of cereal total. The price per pound, it says that my goal is to have it cost $3.75 per pound. And so the total cost for my mixed cereal will be 60 times $3.75, which is $225. And as for my equation, since I want to mix the cereals, I'm going to take the total cost of the oat cereal, add that with the total cost of the dried fruit cereal, and together the total cost of these two cereals mixed together will be $225. Go ahead and show the rest of the work on your own, and I will check for the work tomorrow when I check notes. But your answer, when you get to it, should be 45 pounds of the oat cereal and 15 pounds of the fruit cereal. Okay, now we're moving on to our next practice problem. So again, please make sure you finish the rest of the work of this first problem before you move on to the second one. For our second practice problem, we have the following. Little Miss Muffet had 300 milliliters of lemonade that is 60% acid. She must add water to the solution to dilute it so that it is only 45% acid. How much water should she add? In this mixture problem, you're going to have the following charts set up. So on the left, we have the original solution of the lemonade, the water, new solution. On the top, our categories are total amounts, percent acid, and amount acid. If you think you can fill out the chart on your own, go ahead and do that now by pausing the video. If you can't, just keep the video rolling. Okay, so here are the parts. So the original amount, you have 300 milliliters. And that original amount has 60% of it is acid. So the amount acid would be 60% of 300. Water, you want a certain amount and you don't know how much, so that's X for now. Water is 0% acidic, so amount acid, 0. For the new solution, you want to add some water to this original solution, and you want it to be only 45% acidic, so the amount acid that you want to have is 45% of this total amount. Now, as for your equation, you should have the following setup. You want to set up where you have the original amount of acid plus the added acid to equal the new amount of acid. So the equation we have here is 0.6 times 300 plus 0 equals 0.45 times the sum of 300 and x. And now you're going to solve for x, and you want to check back to the question. It asks for how much water should she add. So check to make sure that your x answers that question. Now we're going to move on to practice problem number 3. Please finish the rest of this work on your own, and I will check for the work tomorrow. And before I take you to this last problem, practice problem number 3, I wanted to share a quote with you since Monday was Martin Luther King Day. And the quote I wanted to share was, or is, "The time is always right to do what is right." Again, the time is always right to do what is right. So hopefully you had a good 3-day weekend, but hopefully a portion of that weekend was just you reminding yourself of the struggles that have come before us to be where you are at now. All right, back to number 3. We have how many liters of water must be added to 20 liters of a 24% acid solution to make a solution that is 8% acid. Please copy this down, and this time I want you to set up the chart on your own. Use practice problem number 2 as a guide, and I want you to submit your response to the form online. How many liters of water must be added to 20 liters of a 24% acid solution to make a solution that is 8% acid? So have a chart, set up your equation, solve it, and make sure that when you solve, you are actually answering what the question is asking. All right, see you tomorrow.